Hey everyone, I'm blinry and I'm really excited to share this project with you all. Nice to see such a packed room. The inspiration for the project is tools like Etherpads or Hedgedog or CryptPad, which I really love to use, like for taking notes during a meeting or to write a draft of a blog post with another person together. But one thing that bugged me about it is that you cannot write code with it together, right? It's only for text. And also, if you kind of need an internet connection, so once you're offline, you cannot access this information anymore. And there are tools to work around like that. For example, several text editors have plugins. This is a plugin called LiveShare for VS Code, which allow you to collaboratively edit code together, files that are on your local machine. But this is a proprietary plugin, and the protocol is not open, so your friends who use Neovim or something cannot really join, which sucks. So obviously we need something better. And that's why I started the Ethersync project, which is an editor-agnostic open source tool and protocol for editing local text files together. I'm not doing this alone, but I did it with a friend, Solid or Moritz. We built most of the stuff we will show you, or I will show you last year together with funding from NLNet. And yeah, I only have 10 minutes, but I will try to show you as much as possible about it. Here's what we have and how it works. The idea is based around connecting directories, project directories. So to make a connection with another person, you would go in your directory of code or something, and then say Ethersync daemon, which starts a daemon and then shows you the connecting command others can use to connect with you. So the other person would run Ethersync daemon and provide a peer in their project directory, and after that, these two directories are now magically synchronized, and files that appear in one directory also appear in the other one. And if you start opening a text file, you can start real-time collaboration in it. I have a little video. Let's see if this works. Right. So you can see on the left side, there's a Neovim instance running and editing a text file. And on the right, you have a VS Code. And yeah, you can edit this content together over the network. And also, you can see other people's cursors in this text, right? This works both with VS Code's multi-cursor feature, for example, and also with Neovim's block cursors. This will be transmitted to the other connected people. Right now, we have plugins for Neovim and VS Code. This is what the VS Code plugin looks like in this extension store, for example. And more plugins are coming up. I will show you later. The daemon synchronizes entire project, so it's not only for a single file, but it's for the entire directory and its subdirectories, which makes a lot of sense if you're editing code. You can not only use text editors, but you can also use external tools. Sometimes you have cases where it's part of your workflow to, I don't know, use the cargo command to change your cargo toml file or something, and then it would be inconvenient if you had to do this in your editor without this external tool. So here's a demo of someone having a file open in Neovim at the left side, and at the right, you have this terminal session where the person starts editing this file. Let's see. Yeah, so here we are appending something from the command line to the file, and over the network, this content change is also picked up and edited into Neovim. Also, if you sort the content for some reason, yeah, it's translated over, which is very convenient for ourselves developing this. And the tool, now I dropped this keyword, is local first. So you always have full access to the content, even if you go offline, right? This is important if you drive through a tunnel in a train or something, and then you want to keep coding on it, and then resynchronize later once you can reconnect to your peer. So now you might be wondering, are they using CRDTs? Yes, we are, of course. This is like, if you have never heard of it, I don't have time to like go into how it works. It's like an algorithm called conflict-free replicated data types, which is very convenient for like making having a situation where both parties can edit, and then once they connect it, it kind of automatically fits together again. But check out other talks if you are curious how that works exactly. And yeah, we're doing peer-to-peer connections, so you don't have to trust a central server. How does it work? Let's look a little bit into that. We wrote the daemon in Rust and the plugins in their respective scripting languages, like Lua and TypeScript. And the components fit together like this. So each peer has a running daemon, which are connected via the internet, and then like make the synchronization of the content. And your editors connect to the daemon on your local machine using a plugin. Let's look at what those arrows mean in more detail. So daemon to daemon, we're using a library called libpeer2peer right now, which is like custom built for situations like this, very flexible. And we're using their private nectar feature to encrypt the content that's going through it. And inside of this connection, we are speaking the raw auto-merge sync protocol. Auto-merge is the CRDT library we're using. And daemon to editor, we have this design goal to make it as easy as we can to write new editor plugins. So we kept the protocol really small. Basically, the editors have to spawn an Ethersync client subcommand and then talk JSON RPC to it. And yeah, we have a small syncing protocol that's kind of inspired by LSP, the language server protocol, because we thought editors support that most of the time anyway. So offering our protocol in JSON RPC format might be like practical to implement. And for this protocol, because the editor is a separate process, we also have to do something clever, and we're using operational transform for that, which is like another approach to like make real-time collaboration, and we're doing it in a one-sided way, where the editor doesn't really have to do much. It can just reject the changes it's getting, which it doesn't apply to its own content right now, and the daemon will do most of the work and send the content later. Our daemon editor protocol is so tiny that we once tried to fit it into a toot. So here it is, in like, I don't know, 250 characters or something. And this is like the core of how the content synchronization works, like experiment how we can like express that. But we also have documentation which goes into more detail. Ethersync is not really a replacement for Git, I would say. It's more like a tool that like works together with it. It's not really a system for rich text editing right now. It's most for plain text. And also, it's not production-ready software, I would say. It has some rough edges, which you, like, for example, one of our open questions is, which makes it a bit inconvenient to use, how do you make, like, connections between two local networks? Right now, what we do is one person opens a port in their router, which is not very convenient. But yeah, we would like the better solution for that. And if you have suggestions on how to do it, let us know. libpeer2peer has this private network feature for encryption, and libpeer2peer also has relays, but I don't think the two fit together in a good way. It's not really intended for that. And yeah, our dream would be like to have a magic wormhole style connection making, where one person gets like 3 English words and then tells that to the other party, and then the other person can connect. 3 ways to get involved. You could write your own editor plugin. I showed you we have like 2 official plugins for Neovim and VS Code, and some other contributors are working on ones for IntelliJ. That one is quite far, and also for Emacs. I linked the PRs here. But you could write other ones for Eclipse, for example, if you're using that. Some kind of web-based editor would be really nice to have. And if you were like really wanting a good time, you could, I don't know, fork Nano or something, and then like hack Ethersync support into it if you wanted. Second thing is to help us improve the syncing protocol. Maybe if someone has like a lot of experience with LSP, for example, you might have suggestions on how to make it more general, to be able to use it with other synchronization tools, maybe. And yeah, what we would really like to do is to have maybe a small group of people who work on refining and standardizing it. And yeah, in the end, it would be nice to have this protocol be able to like use it with other software as well. For example, we heard about the API for CryptPad, and being able to use it with CryptPad would be quite nice. And yeah, the third thing is just to use it and give us feedback. If you find something that's annoying or broken, let us know anything you're missing. And yeah, as the very last thing, what I would really like you to take away from this talk is not that you necessarily have to use our tool or something, but I want you to be unsatisfied with like the status quo. And like the next time you have to pair program using a screen share or something, maybe you are a bit annoyed and have like desire for a solution like this. And that's all I got for you. Here are some links for all the documentation.
Thank you very much. Unfortunately, we don't have time for questions, so don't hesitate to talk about it in the hallway, and we'll prepare for the next talk.